Hi friends, welcome to the graph tutorial by Asim Jain, and in this video we will learn about the adjacency matrix of graph data structure and also the adjacency list. So there are two ways of representing the relationship or the connectivity between two graphs. One is called as a matrix. So matrix is something, a two-dimensional array wherein so let me explain you in a simple way. This is a graph which looks like kind of square, and we know one is adjacent to two. It's like undirected. We have covered that in previous video of this tutorial series. So feel free to jump into that video to understand more about the direction. But in short, if there is no arrow which is defined between two vertices, it is called as undirected graph, which means you can go from 1 to 2 and come back also from 2 to 1. It's a two-way traffic. So the path can be, or the edges can be defined the both ways, right? Now how would you represent this? So you have four nodes. You have 1 2 3 4 here, 1 2 3 4 here. So if from 1 you can directly go to 2, which means they are connected or they are adjacent. So you would type 1 here. 1 means true. It's more or less like Boolean, and when we define it in code, we are also going to use Boolean, kind of 0 and 1, something like that, right? So 1 and 2 are basically, you can go from 1 to 2, so it is 1. And can you come back from 2 to 1? And the answer is yes, so it is 1. But can you come from 1? Can you go from 1 to, like, start from 1 and get to 3? No, they are not connected. So that's why it is 0 here. So same way you have represented. So just think in simple terms. First you plot 1 on one axis, another axis 1 2 3 4. From wherever, from 1 you can go to that node, they will be 1, and rest all will go to 0. You do the same thing for 2 here. 2 to 1, yes, but 2 to 4, no. 2 to 4 is 0, right? So this is a way to represent through a matrix, but it's two-dimensional. Sometimes it takes more processing to work out. So that is why there is another way also to represent it through list. Quick recap is, this is a directed graph wherein this is a one-way traffic. So from 1 to 2 you can go, but from 2 to 1 you cannot come back. So that is why if you see 1 to 2 is 1, but 2 to 1 is 0, because you cannot, it doesn't form any path basically. So this is how you would represent the directed graph. Now coming back to the list representation, how a list would be represented. So what we do is, this is undirected 1 2 3 4. So imagine this is a vertex a1, and you for example, you are connected from a1 to, you can go to 2 and you can go to 4. So you can represent it through a linked list. So you don't have to draw a matrix. You just directly define that whatever are the entries in this linked list, or probably the array, single dimensional array, they are the adjacent points. Same thing if you represent in the directed graph, then from a1 you can only go to a2. So that is why 3 is not even mentioned here. From a3 you have two connectivities, like two vertices. So like from 3 you can go to 1 and then go to 4. Yeah, so we are done. Like, that's what I wanted to cover as part of this video. I'll quickly recap that there are two ways to represent the graph. One is adjacency matrix, which is a two-dimensional array which goes 0 if you cannot go from one particular point to another in that direction. And if you want to represent it, like, just list out all the points which are directly connected, you would use the adjacency list basically. Thanks for watching this video. Please like and subscribe if you like this, and then in next lecture we will do the coding to represent the graphs in code. Bye.